Well, hey there, we are going to continue our acid-base chemistry discussion with this video today. And first thing we're going to do is kind of go over what I want to get accomplished in this video, review a little bit of what we talked about last time. So what I want to be able to do, and you're going to see a couple of water molecules here that we've already talked about, is I want us to be able to describe at the end of this what an acidic solution is, what a basic solution is, and what a neutral solution is, right? And to do this, we're actually going to talk about water. Now, I want to make sure that we review a couple key concepts that we have to make sure we understand before we can move on, right, to discuss how water molecules react to form acidic, basic, and neutral solutions. And what we need to make sure that we understand is what an acid and a base is first. So an acid, as we discussed earlier, is what's called a proton donor or a hydrogen ion donor, okay? That's what an acid is, right? And we discussed earlier why a hydrogen ion, H+, equals a proton. So we don't necessarily need to get into that. We already had some questions in class regarding that. So a base, okay, what a base is a proton acceptor. Now, these two key concepts are going to be really important for us to understand how water molecules can actually act as an acid and a base, okay, together. So if you have a water bottle right now that is of pure water, we're going to discuss how water molecules can actually interact, right? And highlight acidic, basic, and neutral solutions. Because, let's just say, for example, we're going to take these two water molecules here. See, this is the part that's going to get me. I need to try to figure this out. Let's say that this water molecule here is going to function as an acid and this water molecule is going to function as a base, because we talked about before how a water molecule can act as an acid and a base, right? So what these two water molecules are going to do is perform and undergo what we talked about before, which is a proton transfer reaction, right? Now we know that a proton is nothing more than that. So what we can see here, and we can visualize this, is this water molecule here is functioning as an acid and this one's functioning as a base. So what's going to happen here is this water molecule here is going to donate, right? It's functioning as an acid. It's going to donate a hydrogen or proton to that base because that base is functioning as an acceptor, right? It's called a proton transfer. You're transferring a proton from an acid to a base. So what this water molecule here becomes as a result, if it loses an H+, it becomes an OH-, because, remember, water is H2O. You eliminate, right, a hydrogen plus, you're going to have one less hydrogen, and now overall you're going to have a negative charge because you eliminated a positive charged ion. So this acid then turns in to that structure, right? The water molecule, when it accepts its hydrogen ion, is going to become that. So then you can draw a little arrow here. That is what's called a proton transfer reaction of two water molecules. So if you take a water bottle, right, I'm sure everyone probably have a water bottle right now as you're listening to this video. In pure water, you actually have some of this ion and some of this ion in water. It's not always just H2O. Right? And that leads us into a discussion of what acidic, basic, and neutral solutions mean. If you have in a solution of water, right, pure water, right, when it's pure water, the concentrations of these two things are going to be the same, right? So one way that we can, so now I'm starting to realize, this is off script, I'm starting to realize what I can and can't do in a video. So I literally would stop this right now if I was doing this video and just have this video just be proton transfer reaction and it'd be done. So then the next video would be a continuation of this to describe acidic and basic, because I would have to erase this whole thing, right? Because I would have discussed concentrations of these and these. But anyways, this is one of the coolest things I've ever done. It's really neat.